question asks us to find the indefinite integral, notice no bounds, of this function, which remember is finding the general antiderivative of this given function by using our antiderivative rules. If we take the first thing we're going to do here is rewrite this so it's easier for us to take the antiderivative. Notice I haven't taken the antiderivative here. I've just simplified the function above. Negative 3x to the 6th stays negative 3x to the 6th. Remember, this has, when x is to the negative 1 power or 1 over x, we have an antiderivative for that. So we just leave that alone also. But any other function that has a exponential or a exponent in the denominator, we would bring up and write it as a negative exponent using our rules for exponents. So this term becomes 5x to the negative 4. This term becomes negative 4x to the 1/2 power. Remember, a radical is power divided by root, first power, second root. Notice I haven't taken an antiderivative yet. Now let's take the antiderivative of this function. When we do, the negative 3 gets out to the front. I make this, I add 1 to the exponent, so that becomes x to the 7th over 7. We know the antiderivative of 1 over x is the natural log of x. That 5 gets brought to the front. I take the antiderivative again using the power rule. Add 1 to the exponent, becomes x to the negative 3 over negative 3. Same thing here, that negative 4 gets pulled out. Add 1 to the exponent. 1/2 plus 1 is 3/2. Divide by that same exponent. We also add c. Here I just cleaned it up a bit. My coefficient is now negative 3/7, x to the 7th, natural log of x, negative 5/3, x to the negative 3. Remember, with fractions, you keep the numerator of 4 and then flip the denominator, making that 2/3. So 4 times 2/3 becomes 8/3, x to the 3/2. Again, powers of exponents. Here's my general antiderivative of this function.